Dr. M.G.R. Educational and Research Institute and one of the coordinator of this FDP program. To begin with this beautiful thought, let me recall the words of Nelson Mandela. Education is the most powerful weapon which you can use to change the world. It gives me a immense pleasure to welcome you all today for the 5 days virtual faculty development program on next generation AI, exploring the power of generative models and transformer, organized jointly by the Department of Computer Science and Engineering and Department of Cyber Security, Dr. M.G.R. Educational and Research Institute. FDP is a vibrant platform where academic minds converge to explore the realm of artificial intelligence system. Over the next 5 days, we are going to explore more about the next generation AI models with the help of our knowledge and experienced resource person. To formally start this event, I now request Dr. S. Geeta, Dean and Head of the Department of Computer Science and Engineering, to deliver the welcome address. To grace this occasion, we are honored to have I now humbly invite Madam to deliver the inaugural address.
A very good afternoon to one and all here who have come as participants. Thank you from the Department of Computer Science and Cyber Security for the 5-day virtual FDP. I think so many of the faculties should join, and the whole university faculty. I hope so. Geeta would make everybody to join by this time in another 5 to 10 minutes. So this FDP program, in fact, would, since it's a recorded, I also like to see the recorded version after some time, because now I don't have time. And I always appreciate the department for making it possible. So this FDP program, on behalf of the management, we thank our Chancellor and Chairman A.C. Shanmugam and our President A.C. Kumar for giving the department and the university this opportunity to disseminate the knowledge of next generation AI, exploring the power of generative models and transformers, which is going to hit the next few years of our future. In fact, so the future is going to change for each one of us in the world where we live today, and make our life easy. That's what I would say. Not that everybody would be taken away from their job or anything, but we can do newer, creative ones to make our life easy and make things work for us. So this is what we, the future faculty, would teach their students to make this possible within a few, 1 year or 2 years, to make new generative models and make transformations to be made. So I want department Geeta and others to make the faculty from other departments. This is what I want. That's called the faculty development program. And I want the faculty of your computer science, the other departments. And I think so, Geeta, have they all joined together? I couldn't see the number of participants.
Ma'am, yes, ma'am. So far, 204 faculty members have joined, ma'am. 204 faculty members have joined.
Okay.
Actually, 635 members registered. Most probably they'll be joining in soon, ma'am.
So
we don't want to wait.
Our university faculty?
Everybody, ma'am, everybody.
Okay. Right.
Inclusive of everybody.
Okay, so thank you. So I think so this should have taken off, and I think so this can be repeated again and again. This is what I also want from the computer science department, because this is what the knowledge which has to be acquired even for me. That's what I say. It's not for the faculty, for me also. So I think so. I will see the recorded version, Geeta, and go forward. And I acknowledge the department and appreciate the department from bringing it today. And further on, it would continue as a continuous process. Thank you, Geeta, and the management for giving you the opportunity.
Thank you for your in the sense motivator speech, ma'am. It's actually make us to think something different, which we have to know in our AI technology is concerned.
Right, thank you,
ma'am.
But I have to see this recorded version also to share with me.
Sure, ma'am. Sure, ma'am.
So leisurely, I will also learn.
Thank you, ma'am. Thank you, ma'am.
Thank you, ma'am, for your inspiring words. Your vision continues to guide us through academic excellence with your blessings. Thank you, ma'am. So today we are privileged with us Dr.K.Selvakumar, Assistant Professor, Department of CSE, NIT Trichy. To introduce sir, now I invite Mrs. Selvamina ma'am, Assistant Professor, Department of CSE, to give the brief introduction about today's speaker.
It gives me a great pleasure to introduce today's distinguished speaker, Dr. K. Selvakumar, the highest accomplished academic and researcher in the field of computer science and engineering. Dr. Selvakumar is currently working as an assistant professor, grade 1 in Department of Computer Application at the National Institute of Technology, Trichy. With over 16 years of rich academic and research experience, he has made significant contribution in the areas include artificial intelligence, neural network, deep learning, and medical image processing. He holds a PhD in computer science and engineering from the College of Engineering at Anna University, India. He has served in several teaching and research positions at the Vellore Institute of Technology, contributing greatly to the development of computer science education and innovation. Dr. Selvakumar is deeply fascinated about advanced AI technology, and his currently research focused on transformer-based architecture, next-generation neural systems, and intelligent medical image solutions. He has mentored numerous students, published research papers, and actively contributes to the AI research communication. Selvakumar sir is going to speak on topic next generation AI models, challenges and trends in transformer-based systems. Sir, viewers to you. Thank you, sir.
Thank you, ma'am. Okay, I'm going to share my screen.
Sir, we are very happy to welcome you back to our session again.
Okay, madam. Thank you very much. Shall I start?
Yes, sir. Yes, sir.
Yes.
Is it my screen is visible?
Yes, yes, yes.
Right. Thank you for the wonderful opportunity. Before I'm going to start my session, I would like to thank the organizing team from the Department of Computer Science and Engineering, from Dr. M.G.R. Research and Institute. I'm going to start my session titled as Next Generation AI Models, Challenges and Trends in Transformer-Based Systems. This is what my presentation outline today, what I'm going to discuss in this session. What is next generation AI? Why generative models? Why transformers? Then followed by applications and impacts of this next generation AI. There's evaluation of artificial intelligence. Before I'll go for AI evaluation, first of all, I would like to given definition of artificial intelligence, because most of the faculty members are know very well about the definition. It's an rough or generic. That means I'm not going to give complete definition of AI. That means textbook definition
That's
of
it.
AI. Artificial intelligence is an what is field of computer science, aim on building an software or hardware. That means machines, then intelligence like us. So it can solve problems, reasoning, understanding, decision making, understanding the natural language processing like us. This is a textbook definition of artificial intelligence given by Stuart Russell and Peter Norvig. Um, I already mentioned artificial intelligence is a subfield of computer science. It's not only it's an computer science; it integrates together mathematics, psychology, human behavior. That means um, neural networks, mathematics already mentioned, and control systems put together, and then even for the way of that is easy way of understanding artificial intelligence is machines with minds. That's all, machines with mind. So it just defined by rule-based systems. There are various aspects to define and knowledge to the computer system. Using rule-based systems, there is an techniques which are that is incorporated in AI, such as proportional logic, first-order logic, predicate logic, ontology, various aspects. Even we can represent knowledge using these aspects by rule-based frames, table like that. So with that, we can come up with an intelligent machine. Then followed by machine learning. Again, the machine learning is a subset of artificial intelligence. It's an machine learning is an idea, or otherwise for your understanding purpose. Machine learning is an tool to analyze, process and analyze the data and come up with the decision. This is what an the informal definition of machine learning. Then the deep learning is again the subfield of both AI and ML. The keyword deep, which is represent the number of hidden layers which are present in the particular neural network. That means it's an that is integration of neural network with the learning techniques. Okay, then followed by that advanced, that means the future AI, that is generative AI. Mainly, we are going to that is stick on this generative AI part. So mainly, I'm going to focusing on this generative AI. Okay, so I hope we are very clear about how this generative AI is derived from the AI. So we look at this timeline representation of the relationship between artificial intelligence, machine learning, deep learning, followed by generative AI. See, this keyword AI was coined by Dr. John McCarthy during 1950s. Thereafter, it is inherited and developed, and it is acting or this and represented in a different form, that is machine learning during 1980s. Thereafter, in that is in 2010, it became a deep learning, which integration of machine learning with neural networks. The major difference between machine learning and deep learning. I don't want to go for in depth of that. Then that after the deep learning, you see that timeline, that is durations are not mentioned. When 2030 in future, what we are going to focus is next generation AI. There are three major types of AIs. One is weak, or otherwise also known as narrow. The second one is strong, or strong. And then the third one is super intelligence or hypothetical agent. That is intelligence. The first one is that is kind of artificial intelligent devices are going to perform very specific or well-defined task, like a coffee maker or billing machines kind of things. The second one, strong intelligence. The strong intelligence are going to adapt the environment, and it will perform the new task too. For example, if that particular robot know how to ride a bicycle, if the robot is forced to ride a bike, it can perform riding the bike. It's an example regarding strong. And that super intelligence comes under next generation AIs. Actually, the next generation artificial intelligence represents see significant shift from traditional rule-based systems. Sorry. Rule-based systems or discriminative machine learning techniques towards generative, context-aware, and highly autonomous AI systems. AI-based systems are come up with automatic decision making. That means individual decision making, autonomous property. Apart from that, generative. It will generate by its own whatever the inputs are given accordingly. Also, that context aware, that means semantic based, and followed by highly autonomous, already mentioned, individual decision making without any human interaction. So these systems are that is capable of understanding, reasoning, creating, and interacting with humans through natural modalities, such as through text, images, audio, video. Sir, how come or how these informations are extracted by these machines using sensors, camera, okay, recorders, everything. So all are okay, very similar to artificial intelligence definition, whatever we are discussed earlier. But additionally, we are going to discuss with some mathematical terminologies with deep learning along with natural language processing. So in order to understand this generative AI, you should know about NLP, deep learning, and few mathematical functionalities. Okay, right? So that actually this rise of advanced deep learning architectures, such as about various deep learning models, CNN, RNN, LSTM. There are so many varieties. Later on, we'll go for one after another wherever it is necessary. So particularly the generative models. So the generic meaning of generative. Producing something or new thing from the existing, or producing relevant input based things or whatever it is. And that what is mean by transformer. As an engineers, we know about what is mean by transformer. Actually, the device, it's an electrical device which is convert from low that is voltage to high voltage and vice versa. There is a purpose of transformer. So here too we are going to approach the same, where it is in the different form. Later on we'll discuss. So this is a generic terminology about transformer. Transformer based models which is enabled with the AI. So to perform task unimaginable, and even that 10 years back, it is not such kind of tools which are fall under AI categories. Right now, even if you are feeding text to the chat GPT, Gemini, or any kind of AI devices, whatever you need, suppose you need an image or a particular scenery, or anything audio video based video clip, anything which is capable of developing as per our text. Not only that, even it is possible to generate from one form to another form. That's why it is called as transformers. Okay, transformers. I hope the participants are very clear about why the terminology is coined transformers. Okay, generative. So if you are feeding few inputs, based upon that input, it will come up with find that is a bigger outcome. It is unimaginable outcomes, such as you see the coding. If you want to develop a particular 1,000 line of coding, if you are explaining the problem automatically, this kind of models are come up with solutions. Okay, so even it is very much helpful, and this domain of genes, that even that is moleculars and drug designs, whatever it is. So there's a proper definition of the next generation AI. Actually, the next generation AI refers to the advanced generation of artificial intelligence and technologies significantly surpass the capabilities of traditional AI models. So it is very stronger than the older AI systems. These AI systems are characterized by enhanced learning. That means enormous learning capability, and also I mentioned better understanding of natural language, multimodal capabilities. That means not only from the text, not only from the input as an voice. That means audio, all together, text, image, audio, video, uh, graphics, everything. So, and also real-time data integration. So it will process multiple informations like our human brain. Do you know that our brains are going to process information through eyes as well as through ears? Whatever we are looking and whatever we are observing, is it both are matching together? Like that, it is going to perform. So these are all the various features of next generation AI, such as already mentioned. Once again, I'm going to summarize multimodal intelligence. So multimodal means the capable of dealing different types of inputs. It's in the form of text, audio, video, graphics, motion, pictures, everything. Then autonomous AI agents. That means individual decision making capable devices. Then memory enhanced. Already mentioned about some set of neural networks categories, such as that is under deep learning topic, such as CNN, RNN, and that is in the continuation of the same LSTM, long short-term memory. You know about sequential and combination circuit. I don't want to go for in-depth of digital systems. This here, memory enhanced context awareness devices. That means features real time and data generation, data aware generation, smaller accessible models, synthetic data and simulation. That means synthetic data means the data which is going to generated by using a process named as simulation. That's a process which is going to create the data as per the input. That is known as synthetic data. For example, I need the picture background image of, for example, the current topic, next generation AI. So like that, if I'm going to feed to Gemini or Chat GPT or that is Deep Blue Sea, then automatically it is going to generate my scenery or cover picture. That is known as synthetic data. Then okay, these are all the various key pillars of the next generation AI, such as generative models, transformers, large language models, multimodal systems. We are going to discuss about one after another. Okay, right? Okay, right? One by one, right? The first one, generative models. Under this, okay, we'll go for brief discussion about what is generative model and the key concepts. The various types fall under this generative models and everything. And the generative models in artificial intelligence are using machine learning models. Again, sir, what is this machine learning models? Again, you know, when we have to go for machine learning and deep learning, if our data is very restricted, even our computing power also limited, then we have to go for machine learning aspects. If the data is big data, even we have enough computing power, then we have to go for deep learning. Here, the generative models are incorporates AI machine learnings and other aspects to create new data instances that resemble the data they were trained on. That means if you are feeding one image, for example, the image with trees, for example. So if you are training that generative models, then automatically that model is going to create the duplicate images which consist of different uh, tree varieties on the background. But we have to identify which one is exactly matching with the given input. So see here, here there is an model is called discriminative models, which classify or predict the labels. Actually, in machine learning, this is what majorly it is going to perform. One is either it is going to classify or it is going to predict. It is fall under supervised learning based upon the input data. But the generative models learns the underlying distribution of the input data, enabling them to generate a novel content such as text, images, audio, and video. You know the major difference between how the generative models are, that is that recent generative models are working. Traditional AI based or simply machine learning models are going to perform only prediction, classification, grouping. Apart from these approaches, it will not do any other aspects. For example, if you are giving some input, your input as a voice, then it is going to come, okay, convert into a text, or that voice based images, or that voice based equivalent voice, or relevant voice, or combination of all together. It's a video, anything. So here, these are the key concepts involved in generative models: learning, data distributions, types of generative models, and applications are going to discuss. So these are the types of generative models. That is VAE, that means variational auto encoders. Second one, GANs, generative adversarial network. The third one, diffusion models, and the fourth one, how these aspects are normalizing, and it is going in a flow order we are going to discuss. You know about the generic meaning of definition of encoders. Any idea about encoders? As a faculty members, you might have realized about encoders. Actually, the encoders are a kind of device or the circuit which is going to convert the given one form, that is given form of input to another form. For example, if you are processing that is the numerical value through your circuit, encoder circuit, it will convert that decimal number equivalent to ASCII value or binary, whatever it is. That is the role of or the job of encoders, right? Similarly, here too, the generative model based auto encoders, which is going to perform that kind of conversions. That's why these models are named as encoders. So additionally, why it is auto? Auto, it means it is represent the self implementation or self generation of that information data. That's why it is called as auto encoders. Next one, generative adversarial networks, GAN. So most of the faculty members might have that is heard about this GAN and everything. So later on we'll go for brief discussion about one after another. First, we'll go for variational auto encoders, WAVEs. Actually, the WAVEs are the types of generative model. One among the generative model that learns the underlying distribution of data, and it can generate the new kind of data. But it is they are differ from GANs in structure and training. There's an difference. Even GAN also going to generate that data or image or that is items or anything, whatever you are going to feed it to the model. Actually, this ways consist of these are all the aspects. First one, encoder, latent space, decoder, loss function. So the last one is representing what is the application of ways. First, we'll go for encoder. See here, maps input data to a probabilistic latent space. Actually, that mathematical function here is represented as Gaussian. Whenever we'll go for deep learning and this kind of generative AI models, we needed some mathematical support, particularly probabilistic probability and statistics, linear algebra, and other aspects. Particularly image processing aspects. We needed some filtering based aspects and everything. Mainly, whatever I mentioned earlier, those mathematical aspects are fundamentals. Please, you have to go for those mathematical aspects later on. Then only you will be very easy to understand how come inputs are input based or mapped corresponding results or output. Then the latent space means here there's ways assume that the data features can be encoded as probability distribution. Already mentioned probability based distribution, which is going to be. So you know about that binomial Poisson probability distributions aspects. So enabling a meaningful sampling and interpolation, Gauss interpolation and everything. Then decoder, that the reverse function of encoder is decoder. See here, reconstruct the new data samples from points drawn from the latent space, creating new data similar to the training data set. For example, if you are training the model with a large set of particular disease-based data set, then this particular encoders are capable of generating that similar kind of images. Okay, here one more terminology, loss function includes both reconstruction loss and one more is regularization loss. That means reconstruction loss is how close the output is to the input. That is already, that is, we are very familiar in that. Now one more is regularization term, means regularization loss. That means how close the latent space matches the prior distribution. So these are the major applications of this ways, such as image denoising, that means mixing the noise content to the original image. Then anomaly detection, that means the defect detections. Data compression, there are a variety of compression, that means two major compression, such as lossy and lossless compression. In lossy compression, how much percentage that the same content were going to be dropped. Then synthesis of new examples, synthesis generation of duplicate information as per the original originally feeded content and more. So this is an architecture of way. Look at here, encoder, the right hand side decoder. There is an there is a simple that is indicated by latent space. This is a mathematical representation. Already, actually, these generative models are existing. So these kind of generative models are existing in a built-in form. So the researchers and even as an academic people, we are directly using this. Suppose if you want to bring your contribution in this architectural defining aspects, then we have to go for selection of different mathematical model as per our environment or the problem statement, everything. So you have to decide and then go for model selection. That means that particular architecture and different mathematical aspect too. So now this is an summary of the ways we have discussed about encoder, latent space, decoder, and loss function, right? Then these are the various application already shortly I mentioned here: generative modeling, anomaly detection, data denoising, and imputation, semi-supervised learning. And then latent space manipulation, speech and audio processing, healthcare and biosignal applications. That means processing our brain signal, everything. Finance, prediction and analysis, and decision making. To come up with the suggestions, dimensionality reduction, feature extraction, everything. Okay, I mentioned image to image translation and control, data generation, everything. Next, we'll go for GAN. That means generative adversarial model, that is networks. Actually, the GANs are actually a class of deep learning models with two neural networks, such as generator and discriminator. So please, you have to note down. The GAN is a combination of deep learning models with two neural networks, namely generator and discriminator. So that compete in an game theoretic setup. So generator will go for discussion first. It creates synthetic data instances like fake images for your understanding purpose from the random noise. They aiming to make them indistinguishable from the real data. That is, even I can represent it as cloning. It is going to develop an image or anything, any content that is very similar to our original input, but it is not an original, it's a duplicate. So next one, the discriminator, it tries to distinguish between the real data and the fake data, which is generated by the this deep learning model called as generator. Training also required. Both networks are trained simultaneously. That means generator and discriminator. The generator improves in creating realistic data. That means first time, it is like we try to put our father's, that means parents' signature in our progress card when when we are studying in childhood. That means 6th standard or 5th standard. The same thing. So first time it's very difficult to come up with the same gesture of our parents' signature. That means a father or mother. Some 10 times or 15 times or 100 times you would have trained that is you attempted, then you will get finally the same ditto sign. So likewise, generator is going to be get trained accordingly. How? Does the generator capable of developing the duplicate images which very similar to or very closer to the original image. That's why it is needed for training regards generator. And then similarly, the discriminator becomes better at detecting the fakes. That means how the discriminator is going to differentiate which one is duplicate or which one is fake. That much of training which is required. Like our teacher, even though we would have perfectly drafted our parent signature, some faculty members are very much intelligent. Okay, like they can easily predict. Hey, have you signed or that is your parents are signed like that, so that the discriminator also the ability to detect which one is real and which one is fake. So this is the role of a generator and discriminator with the training. Training is common for both the generator as well as discriminator. These are all the applications of this GANs widely used in realistic image synthesis, art generation, data augmentation, and even drug discovery. This is an architecture of GAN. See here, whatever I mentioned, in the earlier slide, generator and discriminator. Here, the same, latent space is coming to the picture. The generator is going to generate, see, the fake duplicate images, which is similar to the real samples or real images which are supplied to that network. Then the discriminator is going to predict, that is, detect which one is real and which one is fake. So suppose, sir, if the generator is not that much well trained to generate the exact image, whatever it is provided really, then what will happen? Which is going to get trained. Then, sir, if the discriminator is not in a position to exactly identify which one is fake, then in that case, discriminator also going to be fine-tuned as much as until both the that is components are get well trained for creating fake images as well as detecting the same. Okay, I hope you are very much clear about this generative adversarial network architecture. And this is the first attempt of generator, how it is going to be. And discriminator is going to predict, okay, is it this particular representation symbol is fake or original. Then, okay, see, many attempts later you see here, it is going to be represented as an, you see this, strokes of cat image. See, even more attempts you see here later, generator is come up with this. Okay, you see this, the cat is lying on the, all right, see, so for some sitting place. This discriminator is predicting which one is fake or original. Okay, see, this is an overview of GAN. See this I-dimensional sample space, that is this is call it as latent space. Even, okay, see here, low dimensional and the high dimensional. Then you see this generative network, which is going to generate the fake images, which is similar to the real images. Then the discriminator is going to differentiate which one is real and which one is fake. See here, generator plus discriminator plus adversarial train. So these are all the challenges in generated adversarial networks. Training instability, already I mentioned. Whenever we are going to dealing with neural network concepts, it's a kind of black box. You know about what is mean by white box and what is mean by black box. The black box means, don't think about the color. That means we don't know about that what is that functionality which is defined inside that particular circuit or that mechanism, but we are going to approach it. For example, consider the TV remote or something. While you are pressing that power button, device, that means anything TV or that air conditioning system, whatever that remote which is relevant to, which is going to power on. And if you want to control while we are pressing channel change or volume, anything, it is going to perform. But okay, internally, what kind of technology or how the signals are interfaced, how the TV is recognizing such kind of signals, doesn't know. That is known as black box. Similarly, here in neural networks, also a kind of black box mechanism. It's very difficult to understand and then fine tune. That is a problem here in the neural network, because all are deep learning based. Deep learning means neural network based concept. Already I mentioned what the deep terminologies represent. So training instability, how many number of epochs which is required, everything we have to set by trial and error method. Then mode collapse, which mode it is going to be, either we are going to generate or whether we are going to predict. Sensitivity to hyperparameters, how much, okay, which parameter we have to keep more sensitivity or maximum. Computational cost, these kind of generative AI, okay, GANs are required. That is high performance computing environment. That means Google Colab or GPUs kind of environment. Lack of robust evaluation metrics. See, as of now, we people are using, the two measures, standard measures, right? I forgot it right now. Regarding that machine learning aspects, that is okay, right? Then more dropping, difficulty in scaling, ethical and security concerns. Even if we are publishing our very good photos, even our family photos in the social media, we can use such kind of GAN networks. We can come up with duplicate images that may going to make big issues in the social networking, right? So that is called as ethical and a security concern. And dependency on large data set, already I mentioned earlier. If we'll go for such kind of deep learning aspect based AI, that means generative AI or next generation AI models, generative AIs, we need an big data, that is called it as large data sets. Implementation complexity, already told you, we need an very high computing power machines to computing all this kind of huge volume of data set. Next one, the diffusion models, noise addition, denoising, high fidelity outcomes. We are going with this diffusion models. Look at here, the diffusion model with the training data set image and the generated image. See the difference. Definitely there is a slight deviation between the original and then generated. See here, forward and diffusion, and one more, that is reverse diffusion. In forward, we are slowly adding the noise factors. See, the background is completely changed. Thereafter, again, much more noise, and you see here that original images get affected completely with that noise. And then reverse, that noise is slowly little bit is going to be extracted without affecting the theme of that image. See here, then filtered partially, and then grind, and then fine tuned. Okay, so these are all the various popular diffusion models. That is a denoising diffusion probabilistic model, DDPM, score-based generative models, stable diffusions, even DAL E2 and 3, all are a variety of generative AI models. It is going to generate one form of input to another form too. Then you see here LDM, latent diffusion models, and guided diffusion models. And so why we need for diffusion models? High quality outputs. While we are feeding the text to any of the existing generative AI models like ChatGPT, Gemini, it will come up with the corresponding results as per our required results. So in order to ensure that quality of that, we need an diffusion models. Training stability, previously we have discussed some issues in the training stability, mode coverage, flexibility control, versatility, you know about all this in generic terminologies, stable training process and everything, which is adaptable with this diffusion model. Then next we'll go for transition to transformers. Why do we need for transformers? Already mentioned the generic definition of transformers, the limitations of previous models, the self-attention mechanism. Then you see the parallelization for speed. You know what the difference between sequential and versus parallelism. Here the parallelisms are achieved. Improved performance, versatility across domains, facilitated large scale models and everything. So these are all the various key aspects of the transformers. So straight away we'll go for transformers. Actually, the transformers are a type of neural network architecture. See, that has fundamentally changed artificial intelligence, especially in natural language processing and other sequential data tasks. Sir, you mentioned it as parallelism. We'll go for parallelism, and then as well as sequential aspect too. So the transformers are performing this conversion from one to another. That is low to high, high to low. That is voltage viewpoint. Here too, the transformers are going to perform conversions. That may be an text based to image, vice versa, anything. So the transformers process sequential data, like you see text, sequential character by character, line by line, audio at a sequential form. The audio content are going to be, or even images. For example, you consider a video, the video or set of frames which is going to be processed frame by frames. Images by learning contextual. Sir, what is mean by contextual? Later on I'll give some examples. That means semantic based meaningful relationship between the elements irrespective of the distance in the sequence, unlike the traditional recurrent networks. Actually, that RNN is dealing with time-based data, but it is not going to do in such a way. It is going to identify the relevance between that wordings, terminologies. Accordingly, it will behave and come up with the text, or image, whatever it is. Actually, they utilize the self-attention mechanism. You know what is meant by self-attention mechanism? That allows every element. That means each word of input, or each line or character, or even here it is word, because the text is going to be processed in the form of words. So input to wait and attend to every other element simultaneously in parallel, capturing long range dependencies that is efficiently. So look at this diagrammatic representation of that. See, transformers. There are two components of which we already discussed: encoders, decoders, along with attention mechanisms. Here, the input is going to be processed by encoder. Already I told you people regarding what is mean by input. That is encoder. How it is going to convert the input. Here, see, the entire input is that is, for example, it's a text. Then it is going to be tokenized. Then it is going to process. There are three values which is going to be that is three items, three components. Sorry, one is key, second one value, query. Later on, I'll go for brief discussion about this. How far these three components are making major impact on this attention model, attention head. Then you see here the decoder is reverse. From that attention model, you see this the previous output which is going to be fed forward to decoder, and it will be processed both encoder and decoder, and it will come up with the output. Look at here. See here how the attention see here, sorry. Right, how the attention model processing. See, the attention mechanism is a powerful technique used in neural networks that allows the models to selectively focus on the most relevant parts of input data when making predictions or generating the outputs. For example, my statement is, my input is I'm going to bank. I'm going to bank to withdraw money. I'm going to bank to withdraw money. If it's my statement, then this attention model is going to come up with the conclusion of that is that user is going to the statement is relevant to transaction, money transaction. User is going to approach money banking. Suppose I'm going to bank for lending book bank, that is representing book bank. So the terminologies, words are going to be approached. See, so already mentioned the three components regarding this attention mechanism, namely query, key, and value. See, the current element or the context the model is focusing on. So which context that statement should be. Then the elements against which the query is compared to compute the relevance. What is the relevance in that statement? Then the actual data or the information associated with each key, which is aggregated based on the attention score. Which one is getting high score accordingly, which is going to predict which context that statement is. I am going to bank, right? So which bank the user represent? Money bank, river bank, that blood bank, book bank, whatever it is. I hope you are very clear about how this attention models are come up with the self decision making. Look at here how the decoders and attention layers are playing a major role. Here the numerical values are going to be fixed according to that weightage. Actually, these weightages are going to be fine-tuned by a trial and error basis. That is, or otherwise based upon the probabilistic model. So please, you have to refer the mathematical models, and you have to come up with the attention model weight and initial weight values and everything. Even sometimes the random values are fixing, but that is, those random values are not giving that much of impact. So that some trial and error basis how these values are going to be fixed, which is defined. Even actually, I'm interested to share my research based hands-on in this presentation, but those works are not published as of now, so that I am not in a position to discuss those examples, specific examples. So once you would have understand about the fundamentals of all these informations, you would have very clear about generators, transformers, LLM, and everything. So you can easily approach all this kind of existing tools to your data, whatever it is, either it's in a medical data or agriculture domain, whatever it is. Okay, so decoders, encoders, how the encoders are dealing about this statements. You see, time goes by quickly. So what it is going to convey, it means it is going to represent urgency, or you have to finish it off quickly, like that. So next, you see here, sorry. Multi-head attention. Actually, the multi-head attention is an extension of that attention mechanism. It allows a model to focus on different parts of the input sequence simultaneously, and capturing the diverse differences in a relationship and patterns more effectively. So why we need for multiple heads? That means see, diverse focus, even capturing the syntax, semantics. That is, if the statement wise that informations are correct, meaning wise it is correct, or improving overall representational power, everything is going to be considered. Then parallelism, again already mentioned, the multiple attention calculation happens simultaneously. So it is going to improve the model's ability to learn complex dependencies and pattern in data. Also robustness, that means adaptness, using multiple heads reduces the chance of overfitting to a single pattern, making the model more generalizable and everything. Look at this, the diagrammatic representation of multi-head attention. So see here that light pink, that is pink colors, are representing that a multi-head attention. So each layer that is inside, these are all the components, or yes, operations are going to be performed. So these are going to be applicable on each and every layer. So multiple layers are going to be combined together and providing these are all the features: diverse focus, parallelism, and robustness. Okay, then one more is the positional encoding. Actually, the positional encoding is one of the mechanism used in the transformer architecture to provide the information about the position of the tokens within a sequence. But program counter, PC, the program counter is going to indicate what is the next instruction which is going to be executed next. That means further. Similarly, the positional encoder also going to define which layer is doing what, and which see here, that is, it is going to provide the information about the position of the token, which one is a token number 1, 2, 3, and so on, n-1 from that sequence. As a transformers operate on all tokens simultaneously, and see this some issues in the connectivity between which token currently it is, which one is previous and which one is the next. That means a parent of the token and a child of the current token, and the order of it is everything. So this positional encoding mechanism is going to overcome all this. This is a mathematical representation of positional encoders. See here, P is representative of positional encoder, sine cos function, where you see this, the POS is a token position, and I is the dimension index. Sir, is it okay? Have we go for the same functionalities? No, whatever the data set which you are going to process, accordingly you can choose this mathematical function, whichever is suitable to your data set. That means you should analyze the data nature, and that data behavior is uh, matching to which particular mathematical function. That mathematical function you have to choose. Okay, so see here, say sine and cosine functions at varying frequencies allow smooth encoding over different positions and enable the model to generalize to sequences longer than those seen during training. But the positional encoding vectors are added to the token embeddings before being input to the transformer layers. Okay, so why it is important already mentioned, because since the transformers analyze tokens in parallel, so that it need a position, which position it is, which one is a prior, that means inheritance properties, ordering, and understanding the language and sequences. Also, it helps the model learn relationship dependent depending on the word position. In English there is an proper syntax representation, subject, verb, object, that means noun, phrase, verb, phrase, like that. So that is going to be represented by the positional encoding mechanism. And also variants includes see these learnable positional encodings and relative positional encodings adapted for different applications too. This is the diagrammatic representation of the positional encoder. See here, positional encoding. Okay, see here, input is going to be embedded here. See, there are a lot of mathematical functionalities, norm function, adding the information, multi-head attention. See here again the softmax layer, whatever you have discussed in the earlier. Okay, see this, the same mechanism is used here. See, okay, then see here. The transformer encoder, you see here now the transformer encoder both are combined together. Now you are very clear about what is the role of the transformer and what is the role of encoder. See that the transformer encoder is a core component of the transformer architecture, mainly aim on processing the input sequences into rich context aware, that means the syntax based, that means semantic based meaningful representations that can be used for various you see downstream tasks like translation, classification, in Google Translator, which is converting from one language to another language. For example, English to Tamil, vice versa, any language it is going to convert. So based upon this transformer encoder, which is going to perform this kind of things. These are all the key components of transformer encoder. One is input embedding and positional encoding. Already we have discussed about positional encoding. So it is combined with input embedding. The second one is stack of encoder layers. Then third one, residual connections and layered normalization. We'll discuss about one after another. The generic meaning of normalization, from one form of representing the number to another form. For example, that age is represented 1 to 100 or 120, right? Up to that 120, it's a maximum, not an 100, which is going to be represented as it is youth, middle, senior, aged, like that. Or otherwise 10, that means thousands are going to be represented by that is k, or 1k, 2k, 3k, like that. So that is normalization. So we are going to discuss about all these three components one after another. See here, input embedding and positional encoding. Actually, the input tokens are first converted into a dense vector embedding. So these are all the terminologies. Dense vector based upon the input terminologies. Then you see positional encoding is added to these embedding to provide information about the order of the tokens in a sequence. Since the transformers do not inherently process the order, that means this is a major functionality of the positional encoder already. Okay, in the previous topic we have discussed. So the positional encoding mechanism is going to provide which one is the verb and which one is the case subject, which one is the object, like that. Then the stack of encoder layers, you see that okay, the transformer encoder consists of stack. That means usually 6 identical layers. It's an a standard representation. If we are going to increase more number of hidden layers, then your contribution will come into this particular type of kind of transformers. It's containing 2 main sublayers here: multi-head self-attention feed-forward neural network. That is FNN. See here, multi-head self-attention, already we have discussed, allows the model to attend to all position of the input sequence to capture contextual relationships between tokens. What is the relationship between the tokens? How it is going to form a sentence which will conveying the proper meaning. Then the feed-forward neural network, simply fully connected neural network applied to each position independently. See, usually consisting of 2 linear transformation with a ReLU function, rectified linear unit. There's an abbreviation of ReLU, activation in between. Okay, it is going to perform. That's what I insisted the participants to aware of deep learning. Actually, in deep learning, all these functionalities are represented. Even it will give a brief introduction about neural networks too. Last one, residual connections and layer normalization. See, each sublayer is wrapped with residual. That means skip connections followed by a layer normalization to facilitate gradient flow and training stability. That means there is a mathematical notations. We have to fine tune the errors and how come the output based upon the input and everything. So that's all about the transformer based encoders. Next, we'll go for transformer decoders. The transformer decoder is actually the part of the transformer architecture responsible for generating output sequences by attending to both previously generated tokens and the encoded input representation. So the encoder is come up with some representation. Based upon that decoders are going to perform. So these are all the key layers in the transformer decoder. Layers. It is not a components, layers, such as masked multi-headed self-attention, multi-headed cross-attention, and feed-forward network. So feed-forward is common for both encoder and decoder. Additionally, see here, masked multi-head self-attention and multi-headed cross-attention. So later on we'll discuss. Next, the major components of this decoder. Again, input embeddings and positional encoding, whatever we have discussed earlier in the decoding mechanism, the same thing which is represented here. You see, the decoder input is typically the target sequence shifted right, converted into embeddings and enhance the positional encoding to supply the order information. Then that see here, the stack of the layers, which is see here. Here the decoder is already mentioned, that is 6 common layers. All are it is mainly divided into 3 sublayers: masked multi-head self-attention, multi-head cross-attention, input embedding and positional encoding, followed by feed-forward neural networks. Actually, this particular masked multi-head self-attention which is going to restricts the previous tokens in the target sequence to maintain auto-regressive properties and preventing information leakage from the future tokens and everything. That means which is dealing about the connections among the tokens, which one is current and previous, next, everything. Then the second one, multi-head cross attention. This mechanism attends to the encoder's output, allowing the decoder to incorporate information from the input sequence while generating the each token. Then the next one, input embeddings and positional encoding. The decoder input is typically the target the sequence shift right. That means preventing seeing the future tokens, converted into embeddings and enhanced with the positional encoding to supply order information. The last one, feed forward neural network. The position wise fully connected network applied to each position independently adding non-linear, okay, see, non-linearity and enhancing expressiveness and everything. The third one is here, residual connections and layer normalization. So each sublayer in the decoder is bundled with a residual connection followed by some layer normalization and to stabilize and speed up the training. Last one is output layer. That is, see, the final decoder outputs are transformed in a linear layer and a softmax function to produce probability distribution to come up with a particular class or what kind of object or which text it is. And look at this, the architectural representation of both, okay, encoder and decoder. See here, how the softmax and the linear functions are going to come up with the classes. The softmax has final class labels and everything. So feed forwarding from the previous layer to next layer and the current layer to next one. Okay, so next we'll go for the training the transformer. Actually, the training transformers involves some specialized techniques and even the best practices to handle their complexity, large parameter size, that means big data, and need for stable convergence. These are all the various key aspects regarding training of this transformer. First one is data preparation. Mainly the data is very much important. So we have to prepare the data accordingly. Then optimizer and learning the rate, scheduling, gradient clipping, dropout and regularization, batch size, how much data you're going to keep for every batch, then gradient accumulation, accumulation and pre-training and fine-tuning, monitoring and debugging. Last one is very advanced techniques going to be. The continuation of the transformers will go for large language models. Actually, this LLMs are advanced artificial intelligence systems, which is based upon the deep neural networks. It is typically built on the transformer architecture, trained on massive amount of text data to understand, generate, and manipulate human languages. This is a main purpose of LLM, large language models, based upon the text information which is come up with manipulation of languages, what we are conveying. So in future, computers are not need of any specific programming oriented interactions. Instead of that, it can understand our regional language based commands. So this LLMs are having various models. See, the LLMs are language models which see with billions to trillions of parameters, which learns statistical patterns, statistical mean, median, mode, context, semantics, syntax from the vast text corpora. Actually, the text corpora means the huge volume. That is a kind of dictionary which has a specific language-based words and its meaning too, and in a self-supervised manner. So they can perform a wide range of language, natural language processing tasks, including language generation, language translation, summarization, question answering, code generation, and reasoning, everything. Okay, so examples, you might have aware of all this: ChatGPT, Google Gemini. So you see this Anthropic, Claude, and other more. Okay, right? And how this LLMs are working, tokenization and embeddings. Actually, the input text is split into smaller units called tokens. Whoever is studied or come across the NLP subjects, spaces of that compilers, lexical, syntax, semantics. So you are very clear about this. So anyway, no problem. Even the word entire sentence is going to be broken into set of units called tokens. Each token is converted into a dense vector embedding that carries semantic information. So I am going to bank. So bank is going to getting attracted more dense vector. Okay. So I am that myself and going to, that is my current operation, that is the process. So everything is going to get the some particular dense. So you see this positional encoding is added to embedding to provide the tokens with the sequence order information, since the transformer process all tokens simultaneously. So the sentences are going to be processed simultaneously. It will come up with the tokens, and according to that tokens that is impact, it will be getting dense. Accordingly, it is going to be stored in that vector. Next, you see this transformer blocks stack. There you see this, the model consists of many transformer blocks stacked sequentially. You see even 12 layers in ChatGPT 2, and okay, right now it is okay, advanced versions are applicable. So it is definitely more layers. Each block has two key components. You see this multi-head, okay, self-attention, feed-forward neural network. Okay, so here already we have discussed about multi-head self-attention. I don't want to repeat once again the same thing. Even feed-forward process, okay, each token independently to transform and okay, enrich its representations. Next, attention mechanisms, okay. Attention mechanism, self-attention calculates relevance between the tokens using query, key, and values, which already discussed. So these scores, okay, determine how much, okay, each token contributes to another's, okay, representation. So it will come up with okay relationship among the okay tokens. Multiple attentions okay heads capture the okay see this diverse linguistic patterns and independences for okay richer understanding and everything. Fourth one, residual connection and layer normalization. With each block, some residual connections add the original input to processed output to the preserve information. Layer normalization stabilizes training and ensure smooth gradient okay flow. That means how the statements are going to be converted. For example, I'm going to a bank. Okay. So if you are going to convert the statement into Tamil, and bank like that, it will come. So suppose if you are going to convert other language, how that okay statements are going to be processed and the positions are a matter of it. Okay. So the next one, output and token prediction. The final output from the stack of transformer blocks goes through the linear okay layered and softmax function that produces probability distribution over the vocabulary subject verb object. From that it is going to be same okay pattern will not be applicable on the okay other languages. In Tamil it is okay different. It's very hectic to come up with the compiler because even you will shuffle the terminologies or that position of the words, you will get the meaning. Okay, the models you predicts the most okay, probable next token. See, condition to all previously seen tokens, enabling okay coherent text generation. So how come it will subject verb object, that is a representation. So see here that the LLMs okay capable okay see here capabilities or there's a various applications of this okay LLMs. Summarization, text summarization, if you are going to process 200 pages of content, it will give only one page of summary about that entire information. Reasoning, justification, translation, already mentioned from one language to another language. Coding, conversion of that is, if you are providing the document related to a particular problem okay, aspects, then it will read the entire solution and it will generate the specific language based coding, everything. Then the prompt engineering, nowadays you people are very clear about the prompt engineering, such as zero shot, few shot, chain of okay thoughts and everything. Zero shot, it is a sequence of reading information, that is called it as a prompt engineering. Even or that is the current AI, okay, generative, that means generative AI tools like ChatGPT, Geminis are dealing this zero okay shots and even few shots and chain of okay thoughts. Okay, right? Based upon this, okay, the RAG systems are formed, retrieval augmented generation. Actually, the systems combines the generative power of large language models with an external information retrieval mechanism to improve accuracy, relevance, and up-to-date okay response generation. Actually, you know, that our World Wide Web WW has informations, but it is okay doesn't know about the machine. That means the machines are not able to understand what is the information, the contents which are existing. So if we'll come up with the semantic aspects of this LLM models, then we can retrieve the content as per our needed information. Even right, okay, still now people are realized this. If you are typing a keyword, you will get the okay information which is okay irrelevant to that keyword. That means we thought of about that cricket player Sachin Ramesh Tendulkar. While you are typing this, you will get okay about not only Sachin Tendulkar records, also what currently is doing and his business aspects, and even Vijay acted movie of Sachin, ex-Sachin pilot, ex-MP, all their informations are going to be displayed. So in order to overcome that, okay, how this, okay, racks are going to be applied. So query encoding, conversion, document retrieval, context, okay, augmentation, that means meaning, okay, awareness based, answer generation, knowledge, okay, updates. So these are all the various aspects of RAG, okay, representation. See here how this multi, uh, model, okay, right? See here that multi-model AIs are going to working. That's multi-model means text and image. Both are, okay, different models. So both are combined together. It is called multi-model. Text plus video, text plus audio, okay, models. I might have seen, okay, everything in the video clip. Subtitles are going in the, okay, that means bottom of the, okay, picture or movie video clip. Also that images, background images, or that okay, the persons, those who are acting in that particular screen, that became an images, text, video, audio, everything is going to be considered as an individual model. That's why it is called it as multi-model, okay, AI. And examples of multi-model, okay, AI is, okay, see here, Chat GPT 4 version, Gemini, clips, that means contrastive language image pre-training. If you are giving text, then it will come up with a beautiful sceneries using this clip tool. It is also a kind of LLM tool. So these are all the, okay, AI for vision, that means object detection, segmentation, image generation, everything. Already, okay, most of the people, okay, most of them are researchers are might have okay, experienced about this, how this object detections are possible, segmentation and image generation. Actually, my one of the research scholar approached object detection, segmentation, image generation, that using GAN, all are, okay, in the medical domain. That means a Down syndrome aspect, prediction of earlier Down syndrome cases. Okay, so only one paper, that means that okay, one work got accepted, but in that work we are represented only idea, not even about the segmentation and image generation. So that only I'm discussing that is that very generic about all this generative AI topics. It will be very much helpful to you people to understand what is what, and while you are using the tool, you'll be very clear about it. And then AI for speech, speech to text, and vice versa, voice cloning, everything. Okay, you might have here, okay, seen that social media, that is video clips. That means small shots. If SPB is singing that particular song, or some other singers are singing that song, how it becomes, or even, okay, people are imitating, if that particular person is mimicking or reading this statement, how come this, okay, particular voice like that. You might have, okay, seen that kind of video clips and everything from your social media connectives. Next, voice cloning, already I mentioned. And even, okay, text to video editing, everything is possible nowadays using this kind of tools. And industry applications, healthcare. This is what my student is doing. Even particularly, okay, next another student is, okay, doing precision agriculture based upon this, okay, generative AI models. Even, okay, we are done up to deep learning aspects results. When my one paper got published based upon machine learning, and one more we are going for deep learning. Recently we have done, okay, work, and my, okay, current one more scholar is going to working on this agriculture based deep learning, that means generative AI, okay, aspects. IoT, obviously, without IoT, it's very difficult to gathering the data. It is dealing about a huge volume of sensor data, in what context it is, how those censored informations are relevant, and what context those informations were gathered. And then cyber security, even most of the scholars are dealing attacks through this RAG, even zero shot, and, okay, you see multi-shot, and, okay, other, okay, aspects. And then healthcare cases, medical imaging, already mentioned. using the GANs, we can generate images, because getting the images, medical images, are very, very difficult. Even they are asking about ethical clearance from the concern, that means from the hospital, everywhere. So instead of that, if we get the sample images, based upon that, we will come up with enormous volume of data using GAN models and everything. And then clinical text analysis, that means my first scholar done this corona-based database with this COVID-19 based data set. From that, gene prediction and gene pattern analysis, and come up with the that means vaccines, medicines based upon the diseases, everything. So for that kind of analysis, we need an this kind of advanced concepts. Then IoT plus AI, sensor fusion, that means edge intelligence. And nowadays, the difference between edge, cloud, and other things. The devices, whatever it is capturing that information, that alone it is going to process and come up with the decision. That decision is going to be fed forwarded to the server. The server is going to analyze the rest of the devices result, and it will come up with the conclusion. That conclusion alone is going to be updated finally. Instead of dealing the entire data and decision making burden is not going to be given to the server. So that is the difference between edge intelligence. Then that agriculture use cases, crop prediction. This is what we are currently doing. Crop prediction using soil nature, NPK aspects, then soil electricity, soil conductivity, and then moisture of the soil, not only soil, and other impacts such as wind blow, wind pressure, rainfall, everything we are considering. And then as of now, we are dealing about all this informations, crop prediction and recommendation through sensory aspect. And future, we are planning to bring the image based disease detection. How do we control the pesticides, and then how do we provide the fertilizers distribution to the that that is that crops which are get affected by the disease and everything. We are planning with come up with a drone. Already I submitted the proposal. We are planning. Even we are incorporating the carbon emission aspect too in this. Then the cyber security application, already I mentioned anomaly detection, threat intelligence, and everything using RAG aspects, zero detection, and hybridization aspects too. And the AI governance, responsible AI regulations. Responsible AI, there are, in AI, there are two major categories, red and blue AI. I don't want to go for in depth of it. And blue AI is always just dealing with ethics and law and order aspects. But red days, it is reverse, just used for even generating threats or dealing other unwanted aspects too. These are all the various challenges and limitations of this generative AI models. Computational resources, already was mentioned. We need an high performance computing resource environment, server, parallel computing, parallel programming, supercomputers, everything, even GPUs, everything. Data bias, you know about it, what is meant by data bias? Because if you are going to dealing with this kind of generative AI models, we need a big data, so it may be biased. You know about what is meant by biased. Everything may be in one particular case class, or it may be uh, one side decision making. And fairness, both that means positive and negative data should be equal, then it is fairness. You see this hallucinations, that means some how can I say that hallucination, it means some imagination, or some that particular that moment that make some kind of Okay, okay, right. You can see that magical moment. That okay, it may be making impact on this. Then context length limitation. Okay, what is the length? You know about the n-gram technique in natural language processing. That means unigram, bigram, trigram, like that. That means how many words it is going to be connected and processed. Single word, for example, only one word is going to be. That means unigram, bigram. That means single word means Sachin. Bigram means Sachin Ramesh. Trigram means Sachin Ramesh Tendulkar. Like that, we are going to connecting that. Okay, so that context length limitation also it will be okay difficult. And explainability and okay interpretability. Okay, you know about that. Explainability means giving reasons, justification, why or how that such kind of decisions are drawn or concluded. Updating the knowledge again, it is okay. We need an expert in that particular domain. So, for example, in the medical domain, we need an advice from the chief doctors and the experts. Then overfitting and generalization, sometimes it may be the machines or models are in the omni okay science condition. Okay, right. And the security and okay misuses, that is also we have to concern how much we people are very closer to the technology and okay that okay devices, the electronic gadgets, that much we are going to okay lose our privacy as well as security. Anyone can misuse. For example, if you are come up with generative models for based upon my voice module, okay, right, module, okay, modulation, then you can feed any kind of your text and you can come generate my own voice. So okay, that is kind of a misusing. So in the future direction, that okay, efficient transformers, okay, edge, okay, large language models, explainable generative AIs, everything. Even we will come up with a much faster and intelligent devices that will read our mind signals. We no need to deal all this okay in the form of text or image, whatever it is. Directly, those kind of models are have the capability of that is grasping our mind signals. Already Elon Musk have done some research in this okay aspect. Even he would have come up with an micro chips which in that is saves or that means which stores all our brain signals. So once that chip is going to be inserted to someone else, they are going to behave like us. You see the future. So the conclusion, whatever it is, the generative and transformer models are shaping the future. This is what okay, I have to convey. Because everywhere, which is very familiar nowadays, everybody is using, irrespective of domains, in engineering domain, medical domain, law and order, even finance, everywhere, marketing, everywhere they are okay using AIs tools. Even okay, they are getting the aid of Chat GPT and everything. Correct. So with this, I am going to stop my discussion. Thanks for your patience listening. I welcome your queries. Madam, please
Thank
unmute.
you, sir. Thank
Uh,
you.
Thank you,
Yes,
ma'am.
sir. Thank you so much, sir. Participants, if you have any queries, you can type in question and answer session. The resource person will answer your questions. One question.
Can I or how can I take this question?
It is, if possible, can explain the transformer work in detail.
Yes. Um, Already I mentioned in a generic that is meaning of transformer, which converts one form to another form. That means the that is a role of electric that is electricity okay viewpoint, which is converting low voltage to high voltage or vice versa. Similarly, here the transformers are dealing that input that is as a text to image or text to audio or text to video kind of things are okay. Even example, Chat GPT is doing right. if you are typing, okay, I need a background image or wallpaper, which is that is relevant to this theme of generative AI, I will get the image. But I inputted as text, only text with the keywords. That text is going to be converted as an image. That is the role of transformer, one form to another form. So any other question? I
One
hope
more query, sir.
understand. Yes, ma'am.
How encoding is differ from positional encoding?
Actually, the encoding is converting one form to another form, I said, right? Positional means which position that word is. Already mentioned, for example, my statement is I'm going to bank. So I am myself going. So where I'm going? Bank. Which bank it is. So further it should have going to come up with the another statement. After that, I'm going to bank and I perform, okay, some transaction. So obviously transaction means money bank. So it will identify and map. So I am going to bank. After some 3 or 4 lines, I may, okay, represent I'm okay. I want to do transaction. So that word is going to be connected. So there, that positional encoding is going to identify that transaction is okay important word, and it will identify, recognize the person is going to okay represent here it as an money bank. Understand? This is the purpose of positional encoding, and also it is going to connect. Already I told you, position encoder is very similar to our PC, program counter, in the CEO computer organizational architecture viewpoint. You know, it is making sequence of execution of our program. Similarly, it is going to represent what is the position it is, and which one is even inheritance. You know about, right? Which one is a parent, which one is a child, and what is the current. Okay, it is going to make a relationship. That is the purpose of encoders and positional encoders. Next.
So ChatGPT uses the concept of transformers, correct?
Yes, obviously it's an transformer is a combination of, right, you see, large language models and it's a transformer. It is converting one form to another form, right? Even Gemini also it is doing nowadays. Even see if you are copy pasting one paragraph, and if you are requesting to give point by point, or if you are expecting MCQ question, or it is very similar to kind of information, everything it is possible.
Yes, sir. One more question. Do you see the future of generative AI moving toward multimodal, unified models or specialized domain optimized models that operate collaboratively?
Yes, in future, that is domain specific you will expect, because already I mentioned various domains, particularly medical domain. This explainable A is going to dictate the doctors. That means guiding the doctors to perform operations. We don't need to bring the experts. So this is what, okay, we can expect explainable AIs in future. It will automatically guide okay how the surgeon want to do operation, where that particular critical area it is, where that particular okay issues happen in that particular part of the human body. Everything is going to guide.
We're almost over.
Next.
So much big question. Considering your experience and knowledge, I would like to ask the general question. How much does AI impact teaching? Is it a blessing to faculty or it will replace us? What about the introducing AI to your young children?
Actually, good
It's not
question. Actually, this AIs are okay. It's actually developed and designed for enhancing human being only, right? It is not going to replacement of human being. You know, okay. No one can. That is, nobody can replace our okay brain equivalent to device. This is what okay. My okay. Okay, viewpoint. Actually, even okay, you can realize that this answer in future. That is or another okay 3 or 4 decades. Um, See, actually, this AI components or AI tools are only helping the okay, aiding the human being, not against or replacement of human being. But they are projecting okay like that, but it is not at all possible. This is what my conclusion. whatever I studied, okay, past 10 years in this domain. Even I came to know that Elon Musk introduced one robot that is going to, okay, similar to our housemaid. Even it will give birth to our baby too. We can programmable according to our okay mindset and everything. But all devices are always devices. It is not equivalent to human beings. Even I don't know when we are going to realize that kind of humanoid robots. I hope everyone has might have seen the movie of that Hollywood movie, The Robot. Here in Tamil Nadu, Rajinikanth acted Indian movie. In Hindi, Shah Rukh Khan acted Ravan. That kind of humanoid robots and all, it will take hardly 3 or 4 decades to replace it. That then, okay, don't worry about it. Even if we are well trained to manage those kind of robots, that then okay, it will okay very much helpful and aiding to us. It is not going to okay replace. Next. Any other questions?
Almost over, sir. Participants, if you have any queries.
They've given, okay, 11 queries.
Okay, sir.
Okay, all are okay, answered most probably.
Yes, sir. Almost you answered all that. So let us wind up the session, sir.
Okay, madam, no problem.
Yes, sir. So, yes, sir. Special thanks to our resource person for answering all the questions so clearly. Thanks a lot, sir. Your insightful and engaging session on next generation AI models, challenges and trends in transformer-based system. Your presentation has laid a strong foundation for the rest of the program. Thank you, sir, for your valuable time and contribution. Thank you, sir. Thank you,
Thank you,
all the
madam.
participants. Yes, sir. Thank you. So, dear participants, feedback link is posted in the Zoom platform. So, it will be active another 15 minutes. Kindly fill the feedback form. Thank you all for all the participants. Once again, we will meet you tomorrow in our next session. That is day 2. The speaker is Dr. Vani Vasudevan, NIT, Bangalore. That under the topic of prompt engineering for next generation generative AI. So thank you once again, and we will meet you tomorrow. Thank you.
Dear participants, if any further